Hi folks, in my last video I was speaking a little bit too loudly and kind of blasted everybody. So I'm going to try and keep my volume down to a minimum. Today we're doing square roots, that's A6, and we'll take a look at them, see what's going on with square roots. What is the negative square root of 49? So we're talking about negative 7. There we go, negative 7. Let's see, the negative square root of 9, which is negative 3. And negative 4. Remember, we're asking what number multiplied by itself gives us 121. So in this case, we're looking at negative 11. There are two square roots. There's a positive and a negative square root. But when they're talking about the square root symbol, this radical, this is called the radical symbol. When we talk about this, we're assuming it's always the positive part. For 1600, notice that there's two zeros, and 16, the square root is 4. One way of thinking about this is the square root of 16 times the square root of 100, which is 4 times 10, or 40, if that helps. The negative square root of 64, again, we're talking about negative 8 in this case. And the negative square root of 9 is negative 3. And, square root of 36 over 25. So really what they're talking about is this, which happens to be the same. You can divide these up. And we know that this is 6 over 5, or 1.2. And we can use however we want. I kind of like 6 over 5. (49 over 25, same deal. We're looking at square root of 49, which is 7 over 5. So we'll write it as 7 over 5. I like improper fractions just fine. What? Oh, gotta read the question. Negative square root. Sorry about that, folks. Next. The positive square root of 6400 is 80. Helps if I actually read the questions on occasion. Let's see, what are the positive and negative square roots of 0.16? Now keep in mind that this is 16 hundredths, if we read it correctly, sorry. And that is the square root, and we want the plus or minus. So we're looking at plus or minus 4 over 10. And it doesn't specify how they want it. So we'll write 4, well, we could write 2 over 5 as well. I think I'm just going to use the 0.4 and the negative 0.4. How's that? (81 over 6400). So now we're talking about the square root of 81, which is 9, and the square root of 6400, which is 80, and no reducing. So it looks like that's it. And 2 over 80, or 1 over 40. I'm going to go ahead and reduce it, since we're talking about plus or minus. The square root of 4 is 2, and we do have a plus or minus, and 6400 is 80, and so that is the same as plus or minus 1 over 40. I think I'm going to use that one. 1 over 40 and negative 1 over 40. And what else? This is the square root of 1/100th. So this is the square root 1 over 100. Be careful, that's not 10, that is 1/10. So we're talking about 0.1. One thing you might want to notice is that notice that the decimal got moved over. When you multiply a decimal times itself, it gets smaller, which is kind of an interesting concept. A few more. 1 over 90. Oh, negative, how about? They're trying to get me again. Need to pay attention. Oh, 196. Okay, so one of my favorite perfect squares is 13 squared, which is 169. And the very next one, 14 squared, is 196. Notice that they're related to one another. So we're looking at 14 with an extra 0. So it's 140 when you take the square root of 19,600. We have those two zeros, which gives us a 10, and the 196, which gives us our 14, and that's over the 121, which the square root is 11. So we're talking about 140 over 11 and negative 140 over 11. Sorry, it looks a little messy when I write with my pen here. Okay, so now this one is the square root, and if we read it correctly, it's 121 over, and it looks like 10,000. That's the 10,000 place. Now you'll notice we have 4 zeros in the denominator. So the square root of 121 is 11, and the square root of 10,000 is 100. So 11 over 100. Now we can write it as 0.11, or we can write it as 11 over 100. And it doesn't specify, so we'll go with 0.11. Now some people are just going to grab their calculator. Not a good idea, because then you need your calculator. This is the plus or minus the square root of 144 over 100, which happens to be 12 over 10, and it's a plus or minus. And we really should reduce fractions, so this is plus or minus 6 over 5. 6 over 5, and negative 6 over 5. Wait, isn't it the same one? Plus or minus the square root of 121 over 100, which is plus or minus 11 over 10, or 1.1 if you like. Whichever way you want to go. I'll go with 1.1 this time. Let me get rid of this real quick. 1.1 and negative 1.1. That's 11 over 14, and we want both. So we're talking about 11 over 14 and negative 11 over 14. And still not done. Okay, 11 over 90, but we want to write we don't want to forget our negative. That's 121, the square root is 11, and 8100, the square root is 90, and we're done. There we go. Almost finished. I like these. All right, so the whole idea is that you want to find a perfect square that's bigger than 113 and one that's smaller than 113. So what we want is the square root, the square root of 100 is a perfect square, and the square root of 121 is a perfect square. So we want the integers that surround it. So the square root of 100 is 10, and the square root of 121 is 11. This is telling us that the square root of 113 is between 10 and 11. We call this interpolation. And you'll notice that we're 13 out of 21 of the spaces in between. 13 out of 21 is almost the same as 13 over 20, or about 0.65. This is actually exactly equal, but since it's only approximation, this is a good decimal. So if I want my answer, I know it's between 10 and 11, and it's 13 out of 21 spaces along. So a good estimate for this is about 10.65. And if you take the square root, you'll find it's pretty close. Now what we're supposed to do, of course, is put our numbers in, which is 10 and 11 are the integers that surround the square root of 113. Square root of 90, square root of 90 is between the square root of 81 and the square root of 100. This is 9 and 10. And if we want an estimate, notice that there's 9 spaces here, but there are 19 spaces here. That's about halfway. So it's about 9.5. So if I want an estimate, it's about 9.5. And if you want to check it, you can square 9.5 and you get 90.25, which is pretty close if you square this. So we're between 9 and 10, almost exactly halfway. Square root of 331. Okay, so this one's a little bigger. So let's see. 289, this 289 is 17, I think. And 324 is 18 squared. So it looks like it's between 18 and 19. 18 is 324, and 19 is 361. Sometime I might go through all of the perfect squares and show you how I memorize those, but they're not too bad. There's a nice little pattern going on here. But anyway, let's see. Which one are we closer to? We want 331, so we're a lot closer to the 24. So we're between negative 18 and negative 19, and we're closer to the 18, and it looks like it's about 0.1, doesn't it? Negative 18.1, because it's much less than halfway. And of course, you could just grab a calculator and enter it, but of course, that kind of defeats the purpose. Now this time we're between 235, so we want the 225, sorry. That's my second 25, that's 15 squared. And 16 squared is 256. So we know we're between 15 and 16, but in this case, it's negative 16 and negative 15 because the negatives are reversed, aren't they? So we need to be a little bit careful here. Make sure I've got it, looks good. So negative 16 and negative 15. $318. So we're close to 324. We're between, sorry, let's see, 289 and 324 are perfect squares. This one again is 17 squared, and this one is 18 squared. So our square root of 318 is between these. And if you want a number, this happens to be 29 spaces for here. From 89 up to 18 is 29 spaces, and from 89 to 24 is 35 spaces. So 29 over 35 is very close to 28 over 35. And there's a 7 common in there. This is an approximation. So we're looking at about 4 over 5, or about 0.8. I would go with about 0.8 for this one. So my estimate would be 17.8 would be my approximation. We want the integers, so we're looking at 17 and 18 for this one. 17 and 18. Okay, so 289 again. 289, they like that one. 324. That's my 17 squared and my 18 squared. And it looks like we're 25 from here to 314. It's 25 spaces. And again, from here to here is 35. So 25 over 35 is 5 over 7. And that is almost exactly 0.7. So we're looking, again, we're reversed. So we're looking at negative 18 because we're looking at the negatives. So we have to reverse these. So we're between negative 18 and negative 17. And since 5/7 is almost exactly 0.7, it's actually closer to 0.707, I believe. So it's negative 18.7. And it looks like we're between these two. 135. So we're talking about 121 and 144. And since 135 is in between those, we know that the square root of 144 is 12, and the square root of 121 is 11. So we're between 11 and 12. If we want to know about how many, there are 14 units between those two, and there are 23 units between these two. And 14 over 23 is a little more than a third, between 0.3, 0.4. Approximately 0.35 is what I would go with. 11.35 would be a good estimate. 11 and 12. And another one, that's going to be 169. That's 13 squared and 196. We're really close to 14, aren't we? See, the 194 is way over here by the 14. But again, we're talking about negatives, so we have to reverse them. So we're between negative 14 and negative 169. I'll write them over here so you can see it. Sorry, it's messy. So between negative 14 and negative 13. And we're way closer to the negative 14, so about negative 13.9. There we go. 162. I'm going to write them in the right order this time. So we've got the negative square root of 162. So my bigger one is the square root of negative 169. And the other one is the negative square root of 144. This is negative 12 and negative 13. Hopefully that shows you a little bit better how these are related to one another. So we're between negative 13 and negative 12. The difference between these looks like it's 18. And the difference between these looks like it's 23. 18 over 23. Close to 4, so it's about 2, let's see, 6 goes in there, 3 over 4. About 0.75, approximately. So it looks like we're at negative 12.75. And between negative 13 and negative 12. And we're all done. Wow, that one took a little while. Spent a little extra time with that missed problem there. Hopefully you got a few hints there, and